Back to ajspeller.com. In today's tutorial, we're going to take this related rates problem and actually create a model using it. A 25-foot ladder is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. Find the rate at which the perimeter of the triangle created between the ladder, wall, and ground is changing when the base of the ladder is 7 feet, 15 feet, and 24 feet from the wall. We've already done the calculations or analytics here by hand. What I have down here is just a concise view of the results of those calculations, and then we're going to create the model using our new calculations here, and then we're going to verify these calculations as well. So we're going to start by placing in information that we know. We know that this here is the ladder. I'm going to label that L. Down here is the ground. I'm going to label X. And then this here is the wall. I'm going to label Y. We're trying to find the perimeter, or the rate at which the perimeter is changing. So we're going to use the perimeter formula. And remember, perimeter is the distance around an object. So here we see the perimeter is going to equal the X value plus the Y value plus the L value. All right. What we want to do here is to make this a dynamic equation so that we can show it on the model. And if we look at the model, you see we have a series of sliders for the ladder length, the change in X over time, or the distance that the bottom of the ladder is from the wall, and we have a time slider so we can move the time backwards and forwards. So we're going to take this equation here and we're going to make it into a parametric equation, and we're going to do that with our first substitution, which is where we're going to say that X is equal to 2t. And the reason I'm going to use the constant 2 is because we know in the problem that dx dt is 2. So for each time unit, we want the X value to be changed by 2 units. And now at this point, we're going to take this equation and substitute it back into the equation for perimeter. So here we have perimeter is equal to, instead of X, I'm going to write 2t. Then I have plus Y and then plus L. Well, now I need to figure out what the equation is for this Y variable. Remember that we have a right triangle, so we can fall back to the Pythagorean theorem, and I'm going to place this down here. We have X squared plus Y squared is equal to L squared. Well, to solve for Y squared, we need to subtract X squared from both sides. And actually, I'm not going to use X squared. I'm going to use what we said X is, which is 2t. So really we have 2t squared plus Y squared is equal to L squared. So I'm going to subtract this term from both sides. So I end up with Y squared is equal to L squared minus the quantity 2t squared. And to get the value for Y, we need to take the square root of both sides. So here we see that Y is equal to the square root of L squared minus the quantity 2t squared. So here when I come back to P, I can rewrite P as 2t plus the square root of L squared minus 2t squared plus L. Alright, now I have this in a form where I can write in or substitute some of these variables and constants for the sliders that we're using. And let's just label those. We know that 2 here is dx dt, so I'm going to change that to dx dt for that slider. The t here we know is for time, and I also have a t here as well for time. Then I've got a couple of L's here. These two L's I'm going to replace with the slider that we call ladder, and I'm going to make those same substitutions here for the X equals equation. So here I can say that X is equal to, instead of writing the number 2, we're going to use the variable dx dt. Instead of writing the variable t, we're going to write the variable time. So now this here, this distance that X is from the wall, we can control with the sliders. For the perimeter, instead of the 2t, I'm going to place in the dx dt times time plus, I'm going to have to come down because I'm running out of room. Instead of L squared, I'm going to place in there ladder squared minus the 2, which is dx dt times time. That quantity is squared, and again I'm going to add on the length of the ladder. So here are the two equations that I'm going to be, or the two expressions that I'll be placing into the modeling tool. All right, so let's go to the modeling tool and begin that process. All right, we're going to start with curve. We want the curve with two expressions. The first expression was dx dt times time. The second expression was dx dt times time plus the square root of whatever the ladder's position is squared minus dx dt times time, and that quantity is squared, and then I want to add on the ladder's length. Alright, the parameter variable is going to be time, the start value is going to be 0, and the end time is going to be ladder divided by dx dt, because that tells us the time at which this entire model is going to finish. Alright, so here we have x, where this 2 times time, this symbolizes the distance of the bottom of the ladder from the wall, and y here is the equation for the perimeter. So what I want to do is I want to place the perimeter as a label on our model here. So I want the y value, so I type y. Oh, you know what? First, let's rename this. Instead of calling this A, let's call this triangle perimeter. All right, now I want the current perimeter because I want to create a label, so I want it's in the y variable, so I'm gonna type a y. I want triangle perimeter, and I want the triangle's perimeter at the moment in time. Basically, I want it wherever the for where the slider is currently set. So I'm going to press enter there, and then I want to pull this off and place this right here under area. Alright, and then I'm going to come in here and I'm going to do some renaming. I want this to be in feet, so let's add that on there. Let's come back to it. Alright, and then let's come to the front, and I want to write perimeter is equal to that value in feet, and I also want to change the size, so I'll select it and let's make it medium size, and then let's slide it over. And you know what, I got an extra equal in there. Can I get rid of that other equal sign? You know what, let's see if I can change A to perimeter. Well, maybe not. Let's just leave it at that for right now. Alright, let's come down now, and we want to find the rate at which the perimeter is changing. So we're going to use the derivative, and we want the derivative of a curve, and the curve we want is triangle perimeter. And now we have that triangle perimeter here. What I want to do as well is let's turn off triangle perimeter. So here we see x is the rate of change of the bottom of the ladder, so we can see the rate at which the bottom of the ladder is moving, and y represents the rate of change for the perimeter. So what I want to do now is create another label here. This time I'm going to use fraction text. The number that I want the y value, so I type y, and I want the y value from triangle perimeter, and actually that's triangle perimeter prime, because I want to get access to where it's the rate at which the perimeter is changing, and I want that at a particular moment in time. And here the units that I need to add here is it's going to be feet per second. So let's do that, and then let's double click here so we can get this other view. So now I can use \frac. The numerator I want feet, the denominator I want seconds, and then for the label again I want to use frac. I want the numerator to be dp, I want the denominator to be dt, and then I want an equal sign here. And then let's click OK. Alright, so that's shown here at the bottom. Let's drag this over. Let's right click on it and let's say absolute positioning. And then let's take a look at two things. Notice first off, when I move the time, we see that the perimeter is drawn in. Let's move it so that we can get an easy perimeter that we can calculate. Let's say that when X is 15, when 15 feet away, well, we got 15 feet here at the bottom. We see a 20, so we see the height is 20, and we know the ladder is 25. Well, 15 plus 20 plus 25 is 60 feet, so we know the perimeter is correct. And now let's go ahead and check each one of these rates of change for the perimeter for the problem that we're working on. So we know that when X is 7, the rate of change of the perimeter should be 17/12. So let's go ahead and set X to 7. So let's move the timer back till we get to 7. Alright, here we are at 7, and it is 17/12. Alright, when X is 15, it should be at a half a foot per second. So let's move this over to 15. At 15, we are at a half a foot per second. And then lastly, let's check it when X is 24. Alright, when X is 24, we see negative 34 feet, negative 34 feet per second. And that is also what we have here. And then of course, if we were to click the play button here on the timer, we see that we can get our animation. Alright, well, this sums up this tutorial by ajspeller.com, and as always, thank you for watching.